Standing honesty on that one. All right, I got a couple other things I need to look at too. I want you to do code.org, Unit 2, Lesson 5. Play Save Your Activity Guides. We will not be doing Lesson 6, preparation for the Create project, and it's not useful. It's just not directly useful to you, so I'm not going to make you do it. There's a Wilson Objects thing. Part number 3, for those of you who are not here. We are making progress on our Explore project. I have your final few. Oh my gosh, where did I set them? No. There were people who weren't here. Here they are. Your final few research papers about Facebook. I'm going to turn those back to them, look them over, and all that sort of thing. So this was a practice for the Explore project. You did not have to find sources, and you didn't have to create an artifact. We're going to practice one more time, one last time, and then I'm pretty much done. After that, it's on you. So what I need for your next Explore project is for you to bring to class a list of 3 ideas of innovations that might work for your Explore project. I want to prioritize best idea, not quite as good, and then the least of the 3 ideas. And here's what we're going to do with them. We're going to save your best idea, because hopefully that's what you're going to do your true Explore project on 5. And we're going to go to work on the second best, the least of those 3, and make that your final practice Explore project. You will create it, you will write the brief paper, all that sort of thing, a complete Explore project using the least of your 3 ideas. What very often happens is you get into it, you're like, whoa, this third best idea, second best idea, I guess that's 3. Second best idea, no, it would be third best, actually turns out to be the best idea. I don't want to use it for my practice project. I want to use it for the real deal. I'll be like, that's fine. You'll get started with, yeah, go ahead. That's fine. Start over with one of your other ideas and make that your final practice one. Does that make sense to everyone? So you may run into a situation where what you plan to use as your best effort isn't really your best effort, it's just your effort. So we have one more chance to work through this thing, get the writing correct, get the get an understanding of how to make the artifact, how to choose and put innovation, etc., 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 etc. And final thought on this: even though you're making a list of 3, after this final practice project, you may throw out all 3 of them and say, I can't do any of these. I have to find something else. That's fine. Whatever you want to write it on, that's good. But I want you to understand every possible, evaluative that can hear you, that can help you choose a good project. Are we good? Dan, you had a question first.
Well, I was just going to, so one of my topics that I came up for my innovation also happens to be like, can I do that, or?
Can you write it about your thesis topic?
Yeah, like a similar topic.
You know, having read the criteria and the rubric for this project from the College Board, it doesn't say anything about you can't use your thesis topic at academic magazine. So, as far as I'm concerned, yeah, sure, fine. Just can't read your thesis,
Okay.
Which means if you get selected as my advisee, you can't use that topic.
Okay.
That's what that means. Anna?
What exactly can this topic be on? Any computing?
Innovation.
So anything that relates to computers?
Pretty much.
that
Or
narrows it
if you
down a
want to
lot.
expand that, anything that really uses digital data, which is a computer probably with a more limited application. Like a GPS is a computer that really only works with global positioning. It doesn't do very well at thing, if you haven't noticed. So any innovation along those lines. Make sense? Okay. And just bring me a list. I want 3 prioritized ideas. This doesn't happen. Are we good? Cool, great. All right, so you know how to do this thing. That's fine. We'll take a look at that. So the object-oriented programming that we need to take a look at. Let's, are you ready?
Ready.
Good, okay. So what you do, you're going to have to download this thing called the Wilson Objects, and you get this really neat little folder. Yeah, looks like that. It's a zip file. And you will get this little non-zip file, which is not that awesome, except that it has within everything you need for object-oriented, train yourself how to use this. So, it also comes with a set of 16 instructions, the 15th of which, or the 16th of which, is the the confusing one. The other ones are pretty easy to do, and I'll do some of them for you here as I'm showing you how to use this. There's also this presentation that teaches you a little bit about object-oriented programming, and this is specific to you, so you need to know how to do it. All right, object-oriented programming. This is why you took this class. Once you're done with an understanding of object-oriented programming, you'll pretty well be ready to do computer programming in college. You'll be ready to take a first semester class without any problem. All right, object-oriented programming. This is what it looks like when you're using BlueJ. BlueJ is really cool, and it shows you this graphic view of the classes and how they relate in a particular programming project. Oops, did that just shrink a little bit? So it's really nice. What you will do in object-oriented programming is you will use a driver, the Holy Grail, and then create separate classes to this thing. It saves a ton of time in coding when you do it correctly. APCSA graduates, would you agree with this?
Yes.
Okay, good. There we go. What it does is object-oriented programming uses methods to make things happen. And that'll become much more obvious when we get through the exercise today. So in the graphic to the right, the project file is the driver, and the example. That's just what it looks like in BlueJ. Questions from my new programmers? Nope? Okay, cool. Now, for everybody, object-oriented programming show one thing to the College Board. The College Board wants to see that you understand and can implement a concept called abstraction. Abstraction exists, and basically it's a process by which in computer programming we simplify things without really caring how they work, and we use other things to represent real-life things. So an example of a real-life abstraction is a stop sign. Like a stop sign itself, unless it's planted right in the middle of your lane of traffic, will not make you stop. Have you experienced this? How many of you have run a stop sign? There we go, I'm so proud. So a stop sign is an abstraction. We stop for stop signs because we understand that this means cease going forward, pause forward progress, at least momentarily before. I was surprised to find in France that they have 8-sided red stop signs with the word stop in English on it. It's like, who would have figured that? Anyway, that's how universal it is. So it's an abstraction. And because we assign meaning to it, it becomes a real life thing. That in effect, it is an abstraction. So a really good technique for implementing abstraction is to use object-oriented programming. It will make the College Board people really impressed if you can do some object-oriented programming in your final Create project. It'll be an easy way of proving that, hey, here's an abstraction I implemented by me a 5. And they'll say, sure, this is great. So objects are abstract, not real representations of things. So to speak, you remember your little car racing game where things went left to right and you dodged stuff? Believe it or not, there was no car on screen. Just kidding. Just pointing out, it's just groups of pixels, and the pixels change on the screen. But there are no cars. Only in our minds do the cars exist. They're abstractions. So you could turn those cars into their very own objects, which is kind of what we're doing today. And suddenly real appears to be real. We give reality to an abstract concept. So for my APCSA grads, this has nothing to do with abstract classes or methods. It has nothing to do with the abstract keyword. Make sense? Make sense?
That makes sense.
Okay, cool, good. Yeah. It's completely different, and it's not intended to be. Okay, so let's see what we got. Okay, so in order to create a new class, basically what you will do when what you could do, and you won't have to in this case, if you were to make a new object, you would have to click on New Class and type in a name for it and hit Enter, and it'll add it to the package, the project that you need it to. Do that. I'm just showing you how this is done. One important thing, when you create a new class, do not name it object with a capital. Don't name it object with a lowercase o. Java already has an object class, and in 99 examples out of 100, that'll never cause a problem. Create an object called object with a capital O. But in 1 out of 100 circumstances, it'll screw up everything. And I won't be able to help you. Why? Because I'm not allowed to look at your code, right? You're on your own. So you're sitting here with a room full of a bunch of other people who aren't good at making mistakes, and you've made a mistake, and they're like, I don't know how to help you, start over. You know, they don't know how to help you. Not name an object. It's just not a good idea. And yeah, then you will add it to the Holy Grail, kind of like a variable, and you'll see an example of this for the exercise today. And in fact, your object is a variable. And I'm going to scroll down, there we go. All right. So, object-oriented programming. It uses a technique, or what they call a paradigm. Why? You know, why does the word paradigm exist? Anyway, uses a technique called object.method programming. Okay? And to get an object to do something, you call it by its variable name, add a dot, and then say what method you want to have happen. So, if we have a line of code in our Holy Grail driver that says Phillips.raiseMyGrade, please. What do you think that method would do?
It's a void.
Ask somebody to increase the grade, right? So, that's good. You're making a request. Hey, computer program, do something. Oh my God, have Phillips raise my grade. So, what's the name of new programmers in this circumstance? Phillips, right. So, conjecturing, what kind of object do you think Phillips might be? A what?
An object.
It's an object, yes. How about something a little bit more specific? Look.
A teacher.
Yeah, sure. Why not a teacher object?
Oh.
You know, you can make a teacher. All right. So, I'm just trying to get you guys to think about it a little bit. Nothing wrong. So, okay, new programmers. Given this line of code, which one of those method name?
Oh, has no. Oh. Well, why?
Helena, you've done this before.
Dan, thank you so much. New programmers, which one of method? Isn't happening, right. What's the variable name? Yes. AP programmers, why did I not use the word this?
Oh,
I'd have to put it in blue, right? Yeah, no. All right, so now how many of you have used functions in math? Right? F of X and all that sort of stuff. You know how when you use a function, you usually pass a number into the function that gets modified, right? Okay, that is a technique that's used in computer programming as well. We call these things parameters, and you will get used to parameter-based, object-oriented programming pretty quickly. Pass in a parameter to a function or a method, generally it gets used for something or it gets modified, just like you would find in use of functions in algebra. Are we good?
I have a question.
Okay. Yes, ma'am.
So, in the third bullet point, wouldn't it make more sense to say I.sed, make it a sed method, and then you transfer the string await multiple things?
Yeah.
I can't believe you, Mr. Phillips.
Yeah, I know, but you know, whatever. I was going to point out that there has been a circumstance ago actually programmed something with the Holy Grail where they made haiku out of their method calls within the Holy Grail. Mr. Phillips, it's a haiku. And you're sitting there counting syllables and you're like, oh my gosh, it is a haiku. You have way too much free time in my class. This is wrong. Anyway, so does that make sense to everybody a little bit? A little bit of analysis of code. I'm talking to the 6 of y'all. Does that make sense?
Yeah.
Okay, good. Excellent. All right, going on to the next thing. We're almost done here. So the instructions say, in the assignment you'll find 2 incomplete classes as well as instructions. Basically, you'll create a program and then modify it to use object-oriented programming. Follow the instructions, and when in doubt, follow the instructions. Oh, by the way, follow the instructions, know which one you're on. If you get confused, ask for help, right? You should be done by the end of the class. If not, we'll fix it next class. So here's the deal. There's your instructions, right? And here's your project as it exists. Now, I need to take something out of this real quick because that's really what we're working towards. Okay, so close out of it real quickly. What you will find out in the instructions that you are given a game driver in a Wilson class. Everything compiles, but nothing happens. So when you double click, I'm just going to close out. When you double click on the package file, pops this up, right click, void main string args. It compiles, it runs, but there's nothing there. That's the way it should be to start with. We go to a couple lines of explanation. File and run, nothing happens, but neither should there be any problems. Then number 2 says, the idea here is beginning using object-oriented programming. Wilson is your object. I've programmed it up to a certain point. You're going to be doing more programming to it in a little bit. Are you with me through number 2, new programmers? Good. Show me thumbs. Let me know what's going on. All right. So object-oriented programming uses the object name method paradigm. And so what I want you to do is code the object called myWilson. So that takes a little code examination. A little code examination. This is the Wilson object. I have named the variable name for the Wilson object. Gentlemen, thank you. I've named the variable name myWilson. And that's a commonly seen thing. When you create an object of type whatever, usually, not usually, but it's not uncommon to see that you'll find the object name preceded by the word my. And that functions just fine as a variable name. Make sense so far? Okay, cool. No thumbs, but I'll take it that that means all right. So object name dot and method. So part number 4, you'll see on line 12, that I've declared. Oh, by the way, line numbers. If you can't see them, click that dialog box. If it's unchecked, you won't see dots and numbers. If it is checked, you will see numbers. Make sense? Cool, good. All right. So I've declared a Wilson object. Now, your instructions say that on line 17, the Wilson is instantiated, which means created. So basically, the Wilson exists and is fully functional. It just doesn't do anything yet because we're not asking it to do anything. New programming. Show of thumbs. Does this make sense? Okay, you're following me. Excellent, good. All right, so what we're going to do first, according to line 5, or instruction 5, you'll begin by drawing myWilson. So the basic code should be the name, which is myWilson, a dot, and the method draw G. Okay? The code should literally be this. And so where this goes is into the driver class. And literally, you are using myWilson to call the draw G method of the Wilson class. So let's put that in there and see what this looks like. Wilson.
That was the same.
Okay? And what this does is allows a Wilson, which is just a very minimal graphic thing, to appear on the screen. That's a Wilson. Every time you run the program at this point, Wilson gets a new color, but Wilson, or he or she or whatever, has its own color, but it doesn't move. It's always the same size. It's always in the same location. Does that make sense to everyone so far? Doesn't make sense to Elena. Okay, all right. All right, so let's look at this thing with the Wilson. Remember that I was calling a draw method for the Wilson. I said myWilson.draw pass it to G. So This is a draw method of the Wilson class, and it receives as a parameter this thing called G, D. It takes care of all of its own drawing. And so what we do is we set color to whatever the random color of the Wilson is. I'll explain more about that later. I fill in a rectangle at X loc and Y loc. Then I set the color to black, draw a rectangle. In other words, I make an outline of it, of the same place. Make sense so far? New programmers, show of thumbs, is that good? Okay, good, excellent. If I change something, my Wilson changes in the driver. Calls the same method, but it appears slightly different.